Today on Component Close-Up, we're going to have a look at some transistors. Now these are not modern transistors, these are in fact, they're all PNP, and to begin with we'll go through, I'll take them roughly in chronological order. We'll start off with some germanium ones. So let's get started. We'll just make a bit of room here and get that out of the way so that we can see more clearly. This is the oldest transistor I have in my collection of transistors. This one is made by Ediswan. Let's see if I can get it a little bit nearer and get it to focus. This is, there it is, you can read there, Ediswan. And this is, I think, a joint venture with Edison and the Swan company in England. The part number here is XB102. This is in a top hat package. You can see that it's in a sort of metal can, which is roughly top hat shaped. Unfortunately, one of the leads is broken off. There's a little paint dot there to show which end of the, I presume it's showing emitter, collector and base. You're going to need to know which end of it is which. That lead's broken off. And now I think this transistor was purchased by my father in the late 1950s because he made a radio. And my mum took that radio with her to the maternity hospital when I was born. So this transistor is most likely older than I am. It's PNP and it's germanium, oldest one I've got. Now what else have we got in the way of interesting germanium transistors? Here is a very familiar brand name, Mullard. Later on either merged or bought by Philips. This is an OC45. It's made in Great Britain. Again, the three leads on the bottom there. There's a stripe on the side, I suspect, for orientation. It looks like it's in a glass package, so underneath this orange plastic sleeve there's some sort of glass. It's a sort of almost like a little tiny test tube in shape and sealed up on the bottom there, and it's full of some kind of grease, or I think it's a silicone grease of some sort to protect the germanium transistor. The actual transistor, of course, inside these things is absolutely tiny. It's only about 1 millimeter at most in size. So that's the OC45. We've got some others perhaps also well known, which is the OC71. Little red dot for orientation there. And what else do we have in that sort of era? We've got, I'll drop on the floor. There we go. We've got, let's look at this one. This is made by, let's get that in focus again, come on. Give it time, it'll, there we go, right, there we go. It's Mullard again, and this one is a GET111, and it's in a copper can. That little bit of metal showing at the end there, just catching the light and showing a little bit of copper colour. It's a metal can, and it's got colour-coded little sleeving over the leads and colour-coded sleeving applied during the use of this thing. This is soldered to a printed circuit board. The Mullard GET111 germanium transistor. Now then, what about this one? This is also a GET. It's a GET882, again in a metal can, no sleeving over this one. Mullard, again a Mullard part. This is looking a little bit like a modern TO5. There's a little tiny tag there to show the emitter, and you've got the 3 leads. There's space for a 4th lead if you need it. Some RF parts, we'll see that in a moment. Had a 4th lead. I don't know what I don't know what age this is because there's no date codes on them. Speaking of that extra fourth lead, here is one which has such a thing. And get this to focus up. It's a Mullard again. It's the OC 170, made in Holland this time. Now this is the connection with Philips. This is made in Holland. It's branded Mullard. And you can see that this has again got the leads coming out the bottom. That dark black disc is actually glass. The can is metal. There are 4 leads, one cut off short. That short one is a screen. So this is an RF transistor for use in a radio or something like that. We're talking not hugely high frequency by modern standards, but it would have been a radio part, certainly into the megahertz, and the screen was simply to make a better RF transistor. And the next one we've got, now this one's an AC 128. Let's get that to focus, come on. There it goes. RS branded, AC 128. Metal can, and again the glass seal. Now the idea of a glass seal on the bottom of these things, the technology of making metal to glass seals was well understood from the days of valves. So you might as well do the same kind of thing, and I think it's glass anyway under there. It could be epoxy of some sort. But the idea of a glass to metal seal was well known, so that was something that it tended to stick with. No date codes, unfortunately, on these. What have we got here? Mullard again, a very popular brand, OC42, British made. That 2N1 might be a date code, but I don't know how to interpret it. There's the seal on the bottom again. All slightly different. This metal sleeve, I think that's a glass seal down there. All slightly different sizes. So I think there's a standardized type called a TO1, which is something like this shape and size. Let's get one that isn't a Mullard. Here's one which is a Japanese part. This is a Hitachi. There we go. Hitachi 2SB 77, and it's made in Japan. No surprise there. So the Hitachi part looking very similar in packaging. Same idea, metal sleeve and glass seal at the bottom there, the 3 leads coming out there. I don't know whether this is germanium or silicon. In the case of the AC128, the A means it's germanium. If it was a BC part, like a BC108, that's silicon, but A would mean germanium. So let's have a look at something which is a little bit more modern. This thing is from the 1970s. It looks a little bit like a modern TO92, but it has a ring around it. It has a sort of rim around the bottom here. So that's, again, it's a PNP transistor. I believe that this is a 2SA 562. They've left off the 2S and just written A562. I believe that's what it is. There's a flat, so the whole thing is D-shaped, so there's kind of a flat on there, which gives you the orientation of the part, like a TO92. Speaking of TO92, here's one. This is exactly like a modern transistor would be. It's a D-shaped package, 2N3703. D-shaped. That's actually marked Singapore there. Look, you can just enough room to write the country of origin. There's some sort of colour coding on the back. Don't know what that means. I think that says TI at the bottom there for Texas Instruments. 2N, so it's a modern numbering scheme. Not unlike something you'd see today. I think this is probably a 1970s part again. So that's absolutely like a modern transistor would be, and this one here is also very, very similar to a modern part. This one is, it's got a C there, could be a 2SC1353. Domed top, again a flat to indicate orientation. Almost at the end of them now. I've got a couple of other interesting ones here. This one is this is a funny shaped transistor, and BC158. So now we've got a BC. So this, although it's PNP, this is actually silicon, BC158, and its shape is not D-shaped, but it's kind of half an octagon, I suppose, the best way to describe it. And the leads at the bottom here are bent, and they're not round wires, they're little flat pieces of metal. This is a package called Lockfit, and you can see little barbs on the side of the, that's not solder, that's actually part of the lead. These were intended for PCB insertion, so the idea was that you could insert this into a PCB and it would lock into the board and stay there and not fall out when you turn the board over or handle the board. And an early example of design for PCB assembly as opposed to tag strip or point-to-point wiring. I don't think these are made anymore. I think that probably was made by someone like Philips. I certainly had a set of these in my electronics kit from Philips, electronic engineer kit in the 70s, in that type of package. Here's one, BSW33, little slim, almost like an integrated circuit. This is in some kind of black epoxy package. Again, the leads are not round wires, but little flat pieces of metal. And finally, the one that's one of my fave types of transistor packaging. This one is a style which was very popular on some British manufactured transistors, particularly the ZTX range. Now there is a ZTX214. It's called E-line. It's like a TO92, which I'll have to compare it with, like finding the right one. There it is. There's our E-line, which is slim. It's got a flat and curved side. It's actually smaller than the modern TO92. The TO92 is ever so slightly bigger. I quite like E-line. It seems to have died out. It seems to have disappeared completely. But it's slightly smaller and certainly quite a bit thinner than a modern TO92. Seems to be in grey epoxy rather than black as well. So that's about my lot for old transistors. Let's get them back in the shop there. An interesting selection, other one I forgot to show you, and that is the TO5 transistor. So this is again a metal can, 2N2905, and we've got little tiny glass seals on the bottom there, emitter marked by the tag, and collector. In this case, there's no insulator there, so that's the collector. It's connected to the canister. The metal is actually live to the collector of the transistor, and the emitter and the base are insulated. TO5 is probably a slightly higher power dissipation than some of the smaller parts. So, a quick run through a whole selection of different packaging styles for PNP transistors. Obviously, I've got lots of NPN transistors, and we'll do another video of those another day. But this being YouTube, I have to remind you, please do, if you like the video, click the like button, and if you wish to see more videos like this, by all means subscribe to my channel, and there'll be more videos just as wacky as this one.